So let's try to use our knowledge of differentiation of power series to find a power series representation of the function 1 over x plus 1 squared. And notice that this is strongly related to the derivative of 1 over x plus 1. And I do know of a power series representation for 1 over x plus 1 using my knowledge of geometric series. I know that that's equal to the sum of minus 1 to the n times x to the n for x between minus 1 and 1. Well, now we have an equation, and the derivative of the left-hand side must equal the derivative of the right-hand side. And the derivative of the left-hand side here is minus 1 over 1 plus x squared, which is very similar to the function we're looking for a power series representation for. And the derivative of the right-hand side is the derivative of a power series, and we can differentiate term by term to get a new power series. So the derivative of the right-hand side is, the derivative of 1 is 0, minus the derivative of x, which is minus 1, plus 2 times x minus 3 times x squared, etc., etc. It's the sum for n equals 0 to infinity of the derivative of the nth term here. So that's equal to the sum from 0 to infinity of minus 1 to the n times x to the n minus 1, which is the sum from 1 to infinity of minus 1 to the n times x to the n minus 1, and this all holds for x values between minus 1 and 1. And that's because the radius of convergence of the derivative of a power series is the same as the radius of convergence of the original power series. So notice how we dropped the n equals 0 term here, and that's okay, because when n is 0, n times x to the n minus 1 is 0, and that was just the derivative of the constant term in the original series. That's really just a cosmetic change in notation for our series. Now, multiplying both sides of this new equation by minus 1, I get that my function 1 over 1 plus x squared is the sum from 1 to infinity of minus 1 to the n plus 1 times n times x to the n minus 1 for x between minus 1 and 1.